no, it's not set up properly. Oh, that's okay. Cool. So my name is Matt Long, and this is a talk about testing programmable infrastructure. So I used to be a tester. I used to be a teacher, and they would always tell me, first off, before we learn anything, first of all, we want to know what we want to learn. We don't just leap straight into it. So I'm going to start off with a statement, so you know roughly what we're talking about. That's that programmable infrastructure is great, but we're missing something. Okay? The point of this talk is we're missing something, and that something is testing, which is surprisingly rarely done. So, hi, my name's Matt, not the most flattering picture of me. I'm a tester. More specifically, I'm a QA consultant for OpenCredo. We're an open source software consultancy, and we specialize in emerging technology. So lots of stuff like DevOps, and like scaling infrastructure and all sorts of exciting technologies. So first of all, I just want to get the sort of clear the air. Like, I'm not a sysadmin. This is a talk about infrastructure. This is very much from a testing perspective. So I don't know about, like lots of like specialist things about like networking or Linux or anything. This is very much me learning infrastructure as I went. And we're going to learn a couple of. I'm going to go through a couple of from the trenches stories about how I learnt infrastructure. So first of all, okay, so this is the Hashicorp Meetup. You guys already know what programmable infrastructure is. This talk is more of a general talk about at people who don't necessarily know it. So I'll go through this reasonably quickly. First of all, let's go through a definition. Programmable infrastructure is the application and methods application of methods and tooling from software development to the management of IT infrastructure. Now, the important thing is we're used to managing IT infrastructure, but we're only just learning to apply software development methods and tools to it. I mean, like Hashicorp is like the kind of company that's building the kind of tools that are allowing us to do this. So what kind of things are we doing this? We're doing automated provisioning, configuration. We're storing our configuration as code. We're also version and source controlling our code as well. Here are some examples. Obviously, lots of Hashicorp tools up here, such as Vagrant and Terraform. But lots of other stuff as well. I'm not going to mention all of these tools in this talk, but obviously, you guys are probably very familiar with this. So, not a very controversial statement. Programmable infrastructure is awesome. It's fast, much faster than doing it manually. Like, I've set up servers manually, it takes a long time. It's automatic. It takes human error out of the situation. So if you're trying to set up stuff, you don't have to worry. The machine is going to do exactly what you tell it to do. And it's all code. So there's a certain elegance to it, and I quite like that. But the thing is, programmable infrastructure, actually all infrastructure really, is inherently complex. Like, we're building complicated applications here. Now, I'm a tester, so I know that, I do this every day. Testing is used to mitigate complexity and risk. Like, we build complicated applications. How do we get around that? We build tests. We check as we go along. But unfortunately, testing in programmable infrastructure is actually quite rare. Like, things go wrong, and we don't know. It's fine until we find out later, and then, oh no. So, what I'm actually going to talk about in this talk, there's going to be two main parts. First of all, I'm going to talk about from the trenches story about how I was a tester on a cloud broker project, which is a very infrastructure-heavy product. Then I'm going to talk about my experiences of building a Kubernetes cluster with OpenCredo. As a tester, so I'm completely unfamiliar with operations, actually delving in and trying to sort of find my feet. Then I'm going to talk about some sort of lessons learned, some common themes from both those stories. So first of all, I'm going to talk about testing a cloud broker. And as I said, this is an infrastructure-heavy product. So the problem. I said, I work for a consultancy, and often clients come to us with their problems. And one large organisation came to us and they said, we want to move to the cloud. Lots of people do these days. But we're wary of lock-in. The thing is, like with IT, we've seen this happen many times, is that large organisations often want to catch on to the latest trend, but what they find themselves is indebted to a big vendor. They find themselves completely dependent on a vendor and they can't move away. And honestly, this is going to happen to the cloud. We're looking at 2 or 3 or 4 big vendors that do everything we want them to do, but if we build our infrastructure on them, we're going to be completely dependent. So obviously they're very, very worried about this. They come to us and they say, how can we get around this? So one of the very simple one of the most simple solutions about this, you can just use multiple ones. You've got a large organisation, each different team just use a different cloud provider. So a few teams can use AWS, a few can use Azure, there's cloud, and obviously there's lots and lots of different providers too. There's a few problems with this. Like all the different cloud providers use different interfaces, feature sets, lingo. They effectively do the same thing, but it's surprisingly hard to know your way around all of them. You get very good at, say, AWS, but then you find that Azure it's kind of the same, but surprisingly different. I mentioned this before. You can't switch easily. Let's say you build all your infrastructure on Azure, and then you're like, actually, AWS does a load of cool things that Azure doesn't. We want to switch. But you can't. Or you can, but it's very painful. And also, if you've got a large organisation, and there's a few teams they're all using different cloud providers, what you can find is that AWS is really good at saying, here's what you're spending on this, what you're spending on within AWS, but you can't unify it between all of them. Because of all these problems, it's tempting, especially for big organisations, to fall back on the most popular. Say 70% of your estate is on AWS, 30% is on Azure. You're like, oh, we all know AWS, why don't we just put everything on AWS? Because of all these problems, what we suggested, we came to a sort of a mutual solution together. What we decided to introduce was a cloud broker. So users, as in different projects with different teams within this organisation, would actually use our cloud broker rather than directly using AWS or Azure other clouds. There are a number of benefits to this. First of all, because they've never used the cloud before, they had quick and easy provisioning. One team previously took 3 months to get their environment ready, which is kind of ridiculous. Like, I think we got that down to about a matter of minutes, about an hour. Common interface to cloud features. No longer did they actually have to learn the specifics, the quirks of each cloud. They could actually, all they had to learn was our cloud broker, and they actually can use all of the clouds just as easily as one another. Templates for common dev environments. So what we would do is we would say, if you spin up this template, then you get, say, three compute instances, VPN, and a database. They don't have to learn how to set all that stuff up. As well as all that stuff, there's built-in best practice. You get monitoring, you get security, it's all set up for you. You don't need to learn that stuff or get it wrong, which can commonly happen, especially if you're an organisation first moving to the cloud. And as mentioned before, one of the problems with using multiple different ones is you couldn't track spending. Well, with this, there's a unified interface for payments. Now, the diagram I showed before is actually, looked quite simple, but the thing is, yes, okay, you're just using a web application to get onto the cloud broker. So the cloud broker, is a web application that users log on to. And it looks quite simple from the outside, but beneath the surface, actually a lot of really complicated stuff is going on. You're talking about a lot of abstraction. This isn't just infrastructure as code, this is abstracting infrastructure as code. And for me as a tester, actually, I don't know. I felt it was extraordinarily daunting. One way you can get around one thing I often do as a tester is you see a complicated application, you see a massive suite of tools, and you see lots and lots of services, and actually you need to just take a step back and think, actually, how are the users using this system? So what I'm going to take you through is a main workflow. It does a lot of different things, this application, but this is sort of the main workflow that they use. So first of all, they log into the web UI. Secondly, they fill in information about what they want. Obviously, they can use a template, or they can choose different resources. Then what the broker will do with that is it will create and bootstrap and make all that stuff. And then your resources are ready. You can use that as a programming environment. Now, if I just go back to those first two things, that's a solved problem for me as a tester. I do that all the time. Like, if you look at like adverts for dead end tests, web testing is the #1 thing they want. There's lots and lots of tools you can use. There's Selenium, Cucumber, there's stuff like Water. You can even use like older tools like QTP. This stuff is more complicated. This is not part of a sort of a normal tool set, if you will. And so you're looking at getting into machines, you're looking at asserting they can do certain things. It's infrastructure testing. So the question is, how do you test infrastructure? First of all, let's think about what kind of things we want to test. Can instances access one another? Now, obviously, if I'm working on a team and I've set up like a few different instances, I might want them to access one another, but obviously I don't want different projects to be able to access each other's machines. Are different services running? So maybe I've got a Jenkins, maybe I've got a pre-made Jenkins box. I want to make sure Jenkins is actually running on that machine when it's started. Do our deployment scripts work? So even if you haven't got a running server, it's like, do the deployment script do what they what you intend to? That's more sort of unit testing of the scripts. Say we've got a pre-made VPN server. Does the VPN server even work? Like, this isn't just, is the VPN software running? Like, does it do what it's intended to? Is it configured properly? Oops, sorry. Or something more basic, like, can I just SSH into it? I've got this box, I should be able to at least get to it. So, if I look at all those different kinds of if I look at those different, like, assertions, to me this kind of seems similar, because I face, like, those kind of problems a lot as a tester. And actually, you can organize it as a testing pyramid. It's quite simple. Like, there's different layers of testing, but this is applying it to infrastructure. Do our deployment scripts work? Well, if you're thinking from a program perspective, do our deployment scripts work is a unit testing thing. Integration is something a bit above, so we've got servers running. So, like, some basic tests for servers. So, are services running? Can we access other stuff? Now, for anything we can't do with integration, we do with functional, like multi-machine kind of things. Does our VPN box work? Can I get into things? Stuff that our integration tests can't do. So, now I've talked about the kind of problem we have, which is I want to test infrastructure. What I want to have a look at is just the different kind of tools you can use for this. Now I'm going to go through a few different tools. They're not all the tools out there. There's lots and lots of different types. There's lots of different tools for lots of different types of situations. But some of the ones we looked at were BATS, SureUnit 2, GOS. There's a family of related tools which are Service Spec, Inspect, and Test Infra. And then there's also Test Kitchen. So the first tools I'll be looking at more for unit testing. So there's BATS. There's no picture for BATS, so I had to use BAT from there. And BATS stands for Bash Automated Testing System. And it's just unit testing for Bash. If you've used anything like JUnit before, it's very similar. You can assert true, you can assert false, you can assert equals. And it pretty much, that's what you can do with it. There's also Show Unit 2. Now, Show Unit 2 is very similar to BATS, apart from its shell unit testing. So it runs on all Born-derived shells. Examples like Born shell, Bash, Dash, and all the others. The thing I found about Show Unit 2 is that when I looked at the GitHub repo for the latest version, it seems to not have had any activity on it for the past couple of years. Which, I don't know, like, if I'm thinking about adopting a tool, I want to see about current support. I want to see whether it's updated. So those are the unit tests. Now let's look at more integration testing. A lot of these tools call themselves server validation. So there's GOS, which is Go-based. But you won't actually be writing any Go because the specs are in YAML, so be more writing YAML. Because it's Go-based, it's minimal, fast, really easy to write because it's just all the specs are in YAML. And it has some neat features. One feature I quite liked is you can set up a health check server with it. So you can set the service running on a machine with the tests, and you curl an endpoint on the machine, and it will return the results of the test to you. Sorry. Unfortunately, if you have GOS, like the thing is, we were testing lots and lots of different machines. We wanted to test dozens of machines. You have to run it on the server for GOS, which is quite awkward because, like, yeah, it was just quite awkward. It was a bit of a deal breaker for us choosing this tool. Also, another deal breaker is there's no Windows support. Some of the machines we wanted to spin up were Windows, so we couldn't have used GOS to test whether they were working. Another tool is ServerSpec. So ServerSpec is also server-based assertions, just like GOS. And ServerSpec is Ruby and RSpec based. It's probably the most famous. If you've heard of any of these tools, likely you've heard of ServerSpec. One nice thing about ServerSpec is, unlike GOS, you can SSH into instances rather than having to run GOS, which you have to run locally. So we can feed ServerSpec just a list of IPs we want to test, and it will SSH into them and test them. There's InSpec, which is written and maintained by Chef, which some of you guys may use. It's very, very similar to ServerSpec. In fact, it started as an extension to ServerSpec. Now it's its own product. It has a different feature set to Chef, to ServerSpec. So there are some things you can test with InSpec that you can't test with ServerSpec. So for example, configuration files, stuff like the examples they use on their website, things like Hashiconfigs and stuff like that. The feature set is more geared towards compliance rather than server validation there. There's also TestInfo, which again is similar to ServerSpec and InSpec, but it's in Python. So if you really like Python, that's an option. Now I talked about unit testing, I talked about integration testing. There's also a test harness up there called Test Kitchen. Now Test Kitchen, unlike the tools I've just been talking about, which are more test frameworks, and you write tests and they pass, fail. Test Kitchen will actually orchestrate your setup, test, and teardown. So you plug test frameworks into it. Examples of test frameworks you can use are BATS, Show Unit 2, RSpec, ServerSpec. There's lots of others too. And it's very popular in the Chef community. I believe there is some sort of involvement from Chef directly in Test Kitchen actually. However, not suitable for our cloud broker. The real strength of Test Kitchen is that it sets up cloud environments for you. That's what our cloud broker does. We don't need something to replicate that. So now I've gone through all the tools, I will talk about what we chose and how our stack and what tools we use in our stack. So we go back to the cloud broker and we look at the main user flow. Users interact with the cloud broker manages the cloud providers. On the left there, we think about the functionality of the cloud broker. Like, there is a web interface that needs to be tested. So what we use for that is a web test framework. And we used tools which were specialized for testing like web pages. Completely we also had an infrastructure test framework, a completely separate repo which validated completely different functions of our application. One thing to point out about this is these are completely isolated. So our web test framework didn't actually spin up real infrastructure, and there's some quite clever stuff there. So it thinks it's spinning up stuff, but actually we don't have to wait for stuff to spin up, and we don't have to pay for it either. But the application thinks it's spinning up stuff, which is quite cool. Whereas for the infrastructure test framework, we used APIs instead of going through the web interface. Now the web tests, as said, we use stuff that was specialized for web testing. So at OpenCredo, we have a test framework which we use all the time. There's a link down there for our GitHub. It's an open source project. And we use Cucumber JVM, Java, and Selenium. However, for the infrastructure tests, we use a different stack. And we use Cucumber again, because these are still acceptance tests. These are user tests. The thing about this, which is quite odd, is that unlike most applications, our users want to see the infrastructure. Like, they're actually going to be using the infrastructure. So for this, we use Cucumber, we use Ruby, and we use server spec, which I mentioned earlier. Now this is how we organize it. So server spec is much more geared towards server validation and checking certain things, but it's not powerful enough to check everything we wanted to set up with it. It's good at checking whether, say, services are running, whether ports are listening, but it's not good at some of the more complicated things we want to do. So it won't simulate SSHing into a box. So for that, we use a mixture of Cucumber and Ruby. You notice I don't mention the unit testing here. I've got some question marks next to it. The thing is, as a tester, I don't write these scripts, and the people who are writing them should be unit testing them. So I'm going to mention those later. So why Ruby? The thing is, like, we've got this Java testing framework, we've got this Ruby testing framework. Why do we choose using Ruby for it? Well, first of all, Ruby has a fantastic testing community. Most of the really awesome testing frameworks I see coming out there, stuff like Cucumber was originally Ruby, Capybara is particularly awesome. I think Water's Ruby-based as well. There's a lot of stuff happening with testing there, so a lot of, and obviously subspec as well. There's a lot of really exciting testing stuff happening there. It's more suitable certainly than Java for SSHing into boxes. I would call Ruby something like a workhorse language where you can just quickly SSH into something. And it's just a lot more elegant for actually doing stuff. Particularly, there's a WinRM gem that we really liked where we can get into Windows boxes and remotely control Windows. Also, our ops are already familiar with it. I think, from what I've heard, Ruby is reasonably popular in the sysadmin community. So a couple of ops on our team were already familiar with it. So that gave us a running start. Particularly because it's a common language actually between, particularly because it was a common language between our testers and our ops, so they could work with one another. It also reduced the tech stack. If we've got server spec tests running in the same repo as our acceptance tests, that means that we don't have to have another language. So for example, if we'd chosen test infra, we'd have had to do Java, Ruby, and Python just for testing. So we ran the server spec tests first, and really they acted more as sort of smoke tests. Ran before everything else. And really quick as well. They ran in a matter of minutes. They catch obvious problems. They caught obvious problems. So if our servers weren't running, it would catch it straight away. But they're not complex. The things it tests are pretty simple, actually, pretty basic. So here's an example of server spec. Not everyone here is probably familiar with Ruby, but to me, this is actually pretty readable. Describe package Jenkins, it should be installed. Describe service Jenkins, it should be enabled, it should be running. And the great thing about this is, even if you don't understand Ruby, or even if you can't code, you can read this. Our business people go in and they could actually see, yes, this is what's happening. Now, Cucumber. Not everyone here might be familiar with Cucumber, but Cucumber is a BDD framework for kind of readable tests, I guess. Each one of these steps runs Ruby under the hood, but you can read this. Yeah, it's very readable. So, if we just go through this, given the environment's been created, and we have the following users, and given a user has the authorization to get in, when they start the SSH session, then I should be able to echo hello world. Quite a reasonably straightforward example, hopefully. Essentially what we're doing is we've got a box and we want to get into it and just echo something out. Now these first bits, we use the Cloud Broker APIs, so we don't access the web, we don't go through that. We create all this stuff just by hitting those APIs. We use some standard Ruby, so as I mentioned, we were using Ruby to handle with SSH sessions, so here, given user is authorized, that's an API call, never mind. But when user starts the SSH session, that's just standard Ruby. And then we use RSpec at the end, so we use some RSpec assertions to make sure that what has been echoed is actually what we expect. Here's an example of one of the Cucumber steps. So this is that I should be able to echo hello world, what it actually looks like. So you've got a command, just echo hello world. We execute that command, so we get some output. We close our SSH session because we don't need it anymore. And then we expect that output to be the text we put in the first place. Now I've gone through our framework in a little bit of detail. Just some thoughts about the success, I guess, of this of our testing approach. So the good. The great thing was we had specialized tests for each layer. We were using things that specialized for web testing to test the web. We were using server spec, which is great at testing fundamental things about servers for testing the servers. And the server spec tests were really, really quick and expressive. But as said before, I think they're really, really readable. In addition to that, for all the things that server spec couldn't test, we had the power of a full programming language. We could do whatever we want. Yes, they're not as readable, but we can utilize all of Ruby. Now the bad. As mentioned before, being a tester, I don't actually get I wouldn't say down and dirty with unit testing really. And I think that might have been a bit of a mistake because what we ended up doing is spending a lot of time and effort on our acceptance testing and our integration testing. There was almost nothing on the bottom. And I blame myself somewhat for that because it's something I should be pointing out. So we had a Java and a Ruby two testing suites, one Java, one Ruby. It was actually really, really awkward switching between them. What would often happen is I would get a story and I would be asked to test it. And I would spend quite a lot of time writing Java, and maybe I'd pick up a few other related stories, and I would end up spending 2 or 3 weeks writing the same code. And then an infrastructure test would come along and I'd be like, oh, I've forgotten all the Ruby I know. Which is just extraordinarily awkward. And I spend 1 or 2 days actually learning the Ruby framework again, and then I could actually get some work done. I'm also out of my comfort zone. As I mentioned, I'm not a sysadmin, and learning a lot of the fundamentals of how networking and Linux and Unix boxes work actually was it's actually very, very intimidating. And I think that's really worth bringing up. I think I can only speak from my own experience, but I think it's probably a pretty common experience for probably plenty of people on the teams you work on as well. Now, I guess I say the ugly, but what I mean by that, I guess, is like the really bad. Starting infrastructure is really, really slow. Like, we wanted to test like whether our boxes were up and running, but it was taking 10 minutes sometimes to wait for things to happen. If you want to test backups, that takes like 15, 20 minutes. And that's not just bad for like the runtime of your tests. Working on your tests, so what I would be doing is I would be writing, oh, let's test this backup, and I would got something wrong, press play, oh no, it doesn't work, but I have to wait 20 minutes to find that out. I ended up spending days and days and days writing the same tests. So it's very, very slow feedback loop. It's also expensive. It's not just one box we were testing this on. We were testing this on maybe 10, 20, 30 boxes, and having them run for hours at a time, it adds up. It adds up quickly. However, despite all that, it was worth it. I wouldn't want a product released that I was responsible for unless all the functionality of it had actually been tested. Yes, testing is it is a cost. It's an ongoing cost. You've always got that tester working on a team, always got time being sucked away to work on tests. But if you actually invest time in a test infrastructure, it pays back. It pays back dividends. Once we're releasing every couple of weeks and we're making changes like, oh no, does everything work? Well, we've got an automated test suite. It'll catch it, hopefully it'll catch it pretty quickly. Right, I'm going to... Sorry, I'm getting really hard. Okay, cool. So that was the first bit, and I was talking about a cloud broker. What I'm going to talk about now is a semi-related story, which is also about testing infrastructure. And this was about building a Kubernetes cluster. And this is more about, you don't need to know specifically about Kubernetes itself. It's more about making a complex making a complex sort of ops application and thinking about how you can test it as you go along. So I'm a consultant, and I spend time on client side. I don't spend all of my time working on client side. I spend a fair amount of time on the bench. I won't say with not much to do, but the idea is how can I spend that time effectively? Now, traditionally we've done self-training, so go off, find something you like, learn it. What we've been doing more and more now is internal training courses. So people know a lot in our organisation about something. So say someone knows a lot about Kubernetes, someone knows a lot about, say, Spark or Kafka or something like that. What they'll do is they'll have a small training session saying, hey, I know a lot about this, I'll train everyone else. So I was put on one of these during one of my bench things, and as a tester I was put on a team to do some DevOps training. I learned quite a lot actually. It's quite astonishing. You work on a team where all these things are being. You learn a lot about roughly what things are from a high level. But once you actually start getting down and dirty, once you start actually doing the code, writing Terraform, writing Ansible, you learn a lot more. So the goal of this training session was to build a Kubernetes cluster, and what we were using to build them was Terraform and Ansible. So what this section will really focus on is these two tools. Now, building a Kubernetes cluster is not a straightforward task. I'm not going to go through specifically all the details of this. But what I'm trying to illustrate here is that, especially for someone who doesn't know any Terraform, or certainly before I started, there's any Terraform or Ansible, it's very daunting. Now, I mentioned earlier that when faced with complexity, like what you can do is you can use testing to mitigate that. So I'm thinking as I'm doing this, and I'm changing things, and trying to make things work. I'm thinking, how do I test this? Can't I just, if I was a dev, because this is a dev activity, I am writing code, and I'm trying to get something working. What do I do if I'm a dev? I write unit tests. I try and make sure I do a little bit, I write a unit test, I do a little bit, I write a unit test, and I build up this suite of tests to make sure what I'm doing is working. Because I want fast feedback. I want to know as soon as I've done something stupid, trust me, I did plenty of stupid things, I want to know straight away. And as mentioned, sorry, I got a bit ahead of myself then, complexity is mitigated by testing. So you guys are probably already familiar with Terraform. In fact, we've got a talk next about Terraform, so I won't go too much about this. So this talk sometimes I give to people who don't know Terraform at all. So Terraform provisions cloud infrastructure, uses declarative files, and it has some support for variables, but it's not quite a full programming language that we use in Terraform. Terraform commands, again, there's Terraform plan, tells you what you're going to change. Terraform apply actually applies those changes. There's also Terraform validate, which I think is reasonably new. You probably know this. Is that a reasonably new? In the last few releases. Okay, cool. Sorry. So Terraform validate, what that will do is it will lint Terraform syntax view. I think the Terraform validate, it will actually do a Terraform validate if you execute Terraform plan anyway, but it's quite useful to get instant feedback without having to do a full plan. This is what Terraform looks like. So in this Terraform 5 sample, it's just in this example, it's spinning up 3 AWS instances. I've used CentOS. It's in the EU West 1A availability zone, just using a T2 micro. Plenty of other things we can set, and there's an example down there of some sort of variable support. So here it's using it's referencing a different AWS key pair that I've declared somewhere else in one of my files. Now, as mentioned, you can lint with Terraform validate, and that will catch obvious problems. So, for example, if you just miss out a variable, and I've done this when moving Terraform code between, say, files or something, you forget to copy it all. Terraform validate will catch that, just like a compiler would if you use something like Java or anything. You can say, hey, you're doing this wrong. So, if you run Terraform validate, it'll get that straight away. It doesn't catch all problems. So, for example, say if I wanted 2 different subnets, but I declared the same subnet side block for them, Terraform doesn't tell you that with Terraform validate. You can do Terraform validate, it'll say it's all fine. You do Terraform plan, it'll tell you it's all fine. You actually have to do Terraform apply for AWS, comes back to you and says, you can't do that. And that takes a few minutes. And I would say that's a reasonably slow feedback loop. I would prefer instant results, really. So what I'm trying to say with this, I guess, is that linting isn't enough. It does some stuff, but it doesn't do everything you want it to. Because devs don't just rely on compilers. Yes, they use them to check that their code's working, but we use other stuff as well. So we need something more powerful. Something like unit testing. So there is a tool out there called Terraform validate. It is not to be confused with the command Terraform validate. It's Python-based unit testing. So what this will do is it will unit test your Terraform scripts. As said, it is not to be confused with the validate commands. These are 2 completely separate things, quite confusingly named. What Terraform validate will do is it will build a map of your resources and properties, just like Terraform plan does. So when you have the output of a Terraform plan, it'll say, I'm making all these things. What it does in that process is it builds a map of resources. And Terraform validate actually uses the same library, I believe, under the hood. So you can make assertions against properties in your map of resources. It's totally offline. You don't even have to do a plan. The plan actually contacts AWS, but this doesn't. However, the problem with Terraform validate is it's really, really new and incomplete. I think it's about a year old. There's a link down there at the bottom to the GitHub project. You can Google search for it, but it's actually surprisingly hard to find, I found. I found out about this because a colleague recommended it to me, and it actually took me quite a long time to find, so I'm just warning you. One thing we're doing actually, because it's new and incomplete, is we've actually forked it. So we're, OpenCredo are contributing back to it, and you can find our fork there at github.com/opencredo/terraform-validate. I would have more information about this. I do believe it's, so one of the things that Terraform Validate doesn't do is it doesn't even work out variables for you. If you assert against a variable, it will actually have the entire interpolation syntax there. We've done some work, so it will tell you, it will work out what the value of the variable is. I would have more information for you. The guy who's working on, the two guys are working on it, one's left and one's gone on holiday, which is not useful, frankly. So, yeah, sorry guys. Okay, so there's unit testing. It's surprisingly bare, actually. It's really hard to unit test Terraform. There's one repo out there, and it's about a year old, and it barely works. So what about integration testing? Now, I talked about integration testing before. There are a number of tools out there. So the first thing I tried was GOS. GOS is really, really easy to get up and running. Really easy. Like, it was a matter of minutes. But unfortunately, it doesn't support remote testing. So I had 3 boxes, and it was great for like testing one. But if you had to remote into the machine, install GOS, copy your GOS test script across into the machine, and then run it every time you span up this server with Terraform. I wrote a bash script for it. I'm sure you guys could do the same. It's kind of frustrating. It doesn't scale well. One thing I did find really useful was Test Kitchen. Test Kitchen has a Terraform module you can use to test your servers. Actually, so you can spin up. I should give some context. So just to remind, Test Kitchen is a test handler. It is a testing handler. So this will actually orchestrate your testing for you, and you can spin up stuff with Terraform in Test Kitchen. There's actually already a talk about this. If you are really interested in this, what I strongly recommend is you check out the talk Untangling Infrastructure Code, and it's by Neil Shamrell Harrington, who works for Chef. That was at Hashicorp in San Francisco. I think it was this year, it might have been last year. Well worth checking out. I don't want to repeat too much of what she talks about in that talk, but if you want to know more about it, I would check it out. Now, as mentioned, Test Kitchen is a test handler, so it manages your test lifecycle. It doesn't do testing directly. You have to use a different testing framework, which Kitchen CI will orchestrate. What we ideally want, what I'm thinking of as my ideal test lifecycle is I want to create all my resources. I want to then configure them with Ansible. I want to test. I want to use some inspect tests, and I want to make sure they all work. And I want to get rid of my infrastructure. I don't want to pay for it after it's already been spun up. The problem is that Test Kitchen doesn't support multiple provisioners. I worked for a long time trying to work out, it's really easy to get stuff spun up in Terraform with it, but it was really hard to get Ansible to then run afterwards. So I could test my Terraform scripts work, but when I wanted to test it was great checking for whether instances were there and configured according to Terraform, but not more complicated stuff that Ansible was doing. And there's been an open issue on this with Test Kitchen for I think 3 years now, so it's been an open issue for quite a while. Now, one workaround we found, we did get this working in the end, one workaround we found is to use a thing in Terraform called the null resource. And the null resource Terraform will create a null resource after everything else. What I've called my null resource here is Ansible, because it's running an Ansible script. And there are 2 parts to a null resource. There's the trigger, which is basically, do I run this null resource or not? I've used all the AWS IDs. So if the AWS instance IDs change any of them, run this entire null resource. And what this null resource will do in that provisioner, so it's a local exec, so it runs actually on the machine that's running Terraform, it doesn't run on each one of the nodes. What it'll do is it'll wait for a bit, because the thing about Terraform is Terraform is finished when AWS says it's finished, but AWS actually takes a little time to initialize your boxes before they're ready. So what it does is it waits for a bit, it goes into the Ansible directory, and it runs my Ansible playbooks. So essentially, this is what we're doing. To Test Kitchen, it actually never sees Ansible. Ansible runs as part of Terraform, which I don't think is ideal. I would prefer to know within Test Kitchen whether Ansible fails or not, for example. If it fails, that looks like Terraform fails, which is not hugely useful. So some thoughts about this implementation. So the good. Tooling even exists. You can test Terraform. You can test infrastructure as you go. It is possible, and there's no reason why you shouldn't do it. And you can totally get this test suite working. The bad. As said, there's only one thing I could find for unit testing. It was really, really immature. And I found it very frustrating. And tools are immature in general. Like, the thing you have to remember about programming infrastructure is actually quite a new field. So it's not surprising that the testing tools are also immature. Now, this isn't the ugly, this is the hacky, but be prepared to hack things together. If you want to make things work, you're going to have to potentially look for some workarounds, some hacks. It might not even be possible what you're trying to do. There are lots of combinations of tools out there that don't necessarily it could be that few people have tried them yet. So remember, this is brand new ground. Don't expect things to work. You can get them working, but don't expect them, because this is brand new ground. Like, using tools like we're using from Hashicorp and stuff, we are the cutting edge. Not many people have done this stuff before. The testing tools will depend upon your stack. I had to go to Test Kitchen and use specific modules and stuff. Whatever you're using, you might not be using Terraform with Ansible, you might be using other stuff. You will have to use specific tools to test that stuff. So now I've gone through my two sections, I'm going to talk about some general conclusions. First of all, testing is important. It is important. Once you have any stack of any reasonable complexity, testing is going to pay back massive dividends. But it's often ignored because it's an upfront cost. People don't like upfront costs. We tend to avoid, if there's a big tasty donut on a plate, we want to eat it straight away. We don't think about the consequences. Just like with building infrastructure, we're like, oh, we want to build it. I want to get my Q cluster working. We don't think about the consequences of not having a test suite there. Now, I found with the cloud brokers that our tests are not. This is some of the first times I've ever actually talked to one another and tried to do stuff together. The fact is, we have our comfort zones. I really like testing. I do testing all the time. But I never learned ops before I went on this internal training. And I'd say the same is true of a lot of testers. The tools do exist to do testing, but you must remember they might not work the way you intend, you want them to work. You'll have to find the right solution that you need. Finally, I'll just go back to the actual definition I talked about at the start. Programming infrastructure is the application of methods and tooling from software development to IT infrastructure. The fact is, testing is a software development method. Lots of software developers do testing all the time. There's no reason why we can't also apply it to infrastructure. You'll get all the benefits you do from using it in your software testing as well. Thanks. I'm guessing questions. Sorry. I overrun?
Did you find a reasonable way to test policies, any kinds of policies in AWS, which are usually the source of most issues when deploying infrastructure in AWS?
Gosh, I don't think I actually directly worked with any policies, to be honest with you, like in my testing. So it's like, I said with the Q cluster, we didn't set up any policies, and not with Cloud Broker either. So it's not my domain of expertise.
Around some of that was testing more from the functional side of things. If you set up a policy which wouldn't allow certain instances to see each other, then there's a case of sort of validation that you get onto an instance that you couldn't get somewhere else. So indirect, I think, testing policy and not specific.
So yeah, you might not have all heard that. My colleague Nikki there, who also worked on the project, we test it from a user's perspective. So if there was a policy to not do something, we test that from an acceptance testing perspective. So essentially, all of this is functional testing when it comes back to it. So if you can't, I won't repeat what you just said, but yeah, that was so.
Hi, Matt.
Hi there. Oh, how's it going?
Hey, do you have any thoughts on testing, or maybe experience even testing distributed application, and especially their failure modes? Is that something you... Sorry, next question.
Cheers. I'm afraid not. No. Sorry, I'm sorry. I wasn't what I said.
It wasn't clear from the presentation. Was the broker deploying simultaneously or deploying the application across the 3 environments?
No. So what projects would generally do is they would say, we want this application. We want it to, we want all these boxes, and that would be stored under a team. But generally, like a team would. I'm just trying to think. It was a little while ago now. Generally, a team would. It can. I can't remember. Like, do you want? You know a lot more about it, Nick. Do you want this? Sorry. No. There you go. Oh, there's nothing like that. Oh, sorry. Sorry, Nicky knows a lot more about the nitty-gritty.
I mean, in that particular case, there was a template basically. So in theory, most of the applications or the environments that people were spinning up were in one cloud provider. There's technically no reason to allow the environment to span multiple cloud providers, and that's one of the reasons we use Terraform under the covers, because you can actually interface with different sort of cloud providers. But most of the time, the teams would have, for example, they had a Jenkins set up and it'd say, I want it in Amazon, or actually I want that set up in Azure. So it's generally one or the other, although technically you could span multiple if you wanted to.
So, did you have Terraform deployed in your kube cluster, or was it deploying applications into your Terraform environments? Sorry.
So we had Terraform basically creating the infrastructure in the first place, and then Ansible was responsible for actually creating the kube cluster, and then there was a separate development process which was actually then deploying applications into the kube cluster as pods. So we tried to keep the life cycle separate for the actual application development, because we didn't want them having to spin up a whole set of infrastructure every time they wanted to deploy a new pod.
So you could deploy your kube cluster into all 3 cloud providers at the same time. You could link them all together, and then you could schedule your containers across all 3 cloud providers.
I suppose you could.
In theory, but we didn't do that. In theory, it was in one cloud provider at a time, but technically you could do that, yeah.
I think the assumption generally was that you would want to choose one cloud provider or the other per project. I think that was the general assumption.
It started out that way, but it was flexible to allow both. So it just depended. Nobody quite got to that point. To be honest, I think that was much further down the line. So it was hard to just do it in one for many people. So.
Hey, dude. Thanks for the talk and stuff, but I'm not sure if you've come across AW Spec.
Sorry, I can't see who's speaking. I can't see. Sorry.
Yeah, over here.
I am actually. Like, I cut it out because of time constraints. I probably overran slightly with that talk. I have heard of it, yes. I haven't had the time to properly look at it.
Yeah, it's pretty decent. It's like a server spec, but for AW. Obviously.
For AWS, yeah. No, it's pretty neat, AWS spec. The thing to keep in mind is that with With the cloud broker, obviously that's not suitable because we're talking about checking multiple cloud providers. So we don't want to just test AWS stuff. We don't want to make an entire test framework just to test one cloud provider. I'll be honest with you, with the building the kube cluster, it is something that would have been really useful. It would have been. But unfortunately, I didn't get the time. I'll be honest with you, it takes a lot of time to build test frameworks in one tool after the other, so unfortunately, I don't have experience in it.
Cool. Thank you very much, everyone. Thanks, Matt. So, is Paul Stack